Thank you for that introduction. It's a pleasure to present at the Embedded Vision Summit today. It's exciting to see ML systems are live in production all around us, embedded as components of broader software applications or systems. We've started to see more autonomous driving vehicles. In medicine, robotic arms can assist surgeons. ML's helping diagnose patients and read X-ray scans. There's a huge demand for automation in many industries that ML, computer vision, are propelling. And AI as a field has advanced tremendously with a large step change in quality as a result of advancements in deep learning and other technologies. You can tell your home speaker, for example, to play music, to order groceries, turn off the lights. It's amazing to see ML in more production systems, but many are still in the development stage, and we have a far way to go to reach all of the potential applications. More ML projects end as exciting lab experiments than we'd all like to admit. My goal today is to share some tips around optimizing ML systems so that more get deployed and end up working well in the real world. I had the opportunity to join iRobot as the technical director of machine learning in 2019, joining a company that's been building robots for over 30 years and trying to solve these tough problems. When iRobot started, robots didn't exist in anyone's lives on a daily basis. A robotics industry didn't exist, and embedded computer vision was not a solved problem. Now we're running ML and AI systems in production at scale in millions of homes worldwide. So in today's talk, the agenda is I'm going to share a brief overview of an example problem we're tackling before going into 3 recommended steps to consider in optimizing ML systems for production, around creating clear system goals, tips around data collection and processing, and finally, focus around testing and reproducibility.